Helvetica. Woo! Henri is a fellow Canadian from Toronto, and he's here to talk about web performance. When not freelancing, he has a podcast to talk about what tech people do during their free time. Except he doesn't quite have the time to do it. It's got exactly 1 episode from 8 months ago. And he and Dom are such good friends because this is what Henri posts multiple times a week. Let's see. Okay, we got good morning, Dom. Good morning, Dom. Good morning, Dom. Good morning, Dom. Ring emoji. We know what happened that day. Oh, my favorite. Good morning, Dom. Holiday Monday edition. Yeah, he honestly has got better communication than most boyfriends, right?
Hello.
Yeah. So here's Henri here to say good afternoon.
Merci, Daphne. I think I'm good. Man, I mean, I'm not going to say good morning, Dom, so that's over. But I do want to give a shout out to Tyler, wherever he's at. I don't know. Raise your hand. You know, the GIF format celebrated 37 years last weekend, and I was actually going to do a poll to see, you know, if you pronounced it correctly or you were all grammatical savages. So I spared you. That being said, sorry, I am going to say good afternoon, Dom. Oh, Dom, what's up?
Good luck out here, dude.
Thank you. That wasn't scripted. But I will say, I'm glad to be back in Seattle, or what I like to call US West 2C 1A, home of Gail Devers, last American woman to win the 100-meter gold, birthplace of, you know, Mr. 5G, Bill Gates, birthplace of the other G, Mr. Pantene Pro VG, I don't know. Shout out CascadiaJS. And where, come on now, is this not working? Come on. Oh, I'm going to do this. Where another legend went to the University of Washington, Warren Moon. Any NFL fans here? No? Damn, it's too bad. You know, home of the Seattle Storm. You know, this is not even a demo, it's messing up. Multiple year champions. Obviously super rejoicing here, having a good time, but sometimes, you know, times are not so good. You could be surrounded by good times, people cheering for you, but you could also be sad. And when I look at this picture, this is a person sort of hugging their child. They're super disappointed. They're on the phone, they're trying to figure out what happened. What exactly did happen? Well, I'll tell you. They're trying to buy tickets to the Seattle Storm Indiana Fever game, and they're just trying to get tickets, but it didn't happen. But you know, the WNBA is a hot ticket now, so you got to get on it. You want to make sure things are smooth when you go to their website and try to buy this ticket. So I was thinking like, man, is it that hard to buy a ticket? So performance types, what we like to do is audit sites all the time. So I went to the WNBA site, you know, ran a quick little audit to see what was going on, and I think he forgot his remote.
Is it happening again?
Yo, you left this on.
Oh.
I was like, is someone talking to me? And I was looking under the hood. I was like, oh man, look at all these services going on. There's a lot happening under the hood at WNBA.com. It's a Next.js site, by the way, if you can zoom in and see that. And, you know, performance types, we always look at the metrics. We do audits, we see what's going on. So I dropped it into web page test. At the top, you can see some of the page performance metrics. They are lab metrics. But down below, you can see the real-world usage metrics, and that gives us an idea of what the RUM data is like. So this is what we're going to talk about. We're going to talk about what it's like to load items onto a page today, because the internet is a little complicated. The web is amazing. You can do a lot of things with it, but you want to make sure you're on point. So welcome to my presentation, which I'm calling Anatomy of a Modern Page Load. Who's seen the original film, by the way, that I'm spoofing? Okay, a few of you, so you totally get it. That being said, yeah, this is what we're going to talk about, the modern page load. What is it like? What do we have to do to load resources onto a page? So quickly, my name is Henri. I go by on socials as Henri Helvetica. I got this situation called Command H, what I'll talk about maybe a little later. DevComs, communications, community. I'll get into that a little later. I'm from the greatest city on the planet, which we call Toronto, from the north. Ironically, Toronto is south of Seattle. I don't know what happened there, but somehow I'm the north. I am a bit of a distance runner. I enjoy it. So I've been using this hashtag on social, especially Twitter, hashtag devswrun. I just want to encourage the developer community to sort of stay fit, run at your own pace. Speaking of, we're going to have this run tomorrow. So if you're interested at all, scan this QR code. All the information is there. I couldn't fit it all on one page. I was not going to cut and paste it. But it's going to be tomorrow morning, I think at like 9 o'clock or something like that. I forget what the address is, but all the information is on that QR code. So let's get back to this tragedy. Wanted to get a ticket to the Fever game. Man, a page load is not easy in 2024. Like I said, there's a lot going on under the hood on the web. And there are many, many moving parts. Pages that are full of dependencies, like there's so much going on that just trying to get an image onto a page can be a little complicated. So if we go back and look at the information that was on the page load audit, we had a TTFB, a time to first byte of 886 milliseconds, just under a second. Okay, cool. But that was lab data. The RUM data said something a little different, all right? And again, I'm going to talk about the difference between RUM and lab a little later, but the information, the data that we have is really important for us to process. Now, we know that it's also a Next.js site. So the pass rate for Next.js on the TTFBs is 42%. So we know that for the most part, Next.js sites may have a bit of a challenge getting a proper TTFB. And this data is from the Chrome Web Vitals technical report, which is RUM data. Now, when we look at TTFB, we know that 800 milliseconds and faster is great. Anything 1800 milliseconds and slower is, we consider poor, and anything in between is pretty much met. So we talk about the time to first byte, like how do we get that data out to the viewport as fast as possible? Well, there are several ways, but one of them that we try to encourage is to use a CDN for your HTML. Why the hell not? It will provide all the benefits of a CDN provides for a bunch of other resources. So for example, we know that we've been using CDNs for subdomains, of course. Now, at a rate of 47, and then 53 still aren't, but that can improve. We've been using it for third parties, for sure. But somehow we're not using it for the HTML. So we again recommend that you start everything as fast as possible. Now, I mentioned earlier that I think I mentioned that I'm a runner. So you're going to hear me make some parallels with running. So, for example, the U.S. trials start today, actually, for the the Paris Olympics. I talk about, say, the 100 meters. If you're late out the block, you're probably going to be late or not as fast as the others finishing the race. TTFB is the exact same thing. We want you to get out as early as possible. So again, get started as early as possible with the information onto the viewport. So let's talk about staying fast, staying early. We've discussed this idea of using a new status code, which is HTTP 103, something that the people at Fastly, CDN, and I believe Google were working on. So what that means, ultimately, we're going to talk about the browser, we're going to talk about servers, we're going to talk about server think time, and specifically server think time. When it comes to loading assets onto a page, we want to make sure there are no delays. And server think time is ultimately a delay, even as little as 200 milliseconds. Now, by definition, it'll say something like this. This allows a browser to pre-connect to sites or start preloading resources even before the server has prepared and sent that final response. Now, I'm going to compare it this way. You're at a restaurant, you're with your partner, whatever, and you might order calamari because you both like calamari. Server's like, I got you. They take off, make that order, they come back with the calamari, but they also come back with your entree, which is jerk chicken, rice and peas, and fried plantain. Yes, my favorite. In the building. So what is happening there? We are avoiding another trip of having a waiter come by and ask you what you want as an entree and go back and get it. We are actually getting some of the resources ready out the gate and bringing them out to you. So that is essentially what HTTP 103 is going to be all about. Now, it's supported by all the major browsers. The only challenge that, you're going to have a little bit of server configurations to take care of. All right? Now, let me just check something out here and make sure I'm all gravy, and I'm absolutely gravy. Now, let's talk about some other items. Things like the LCP, largest contentful paint. By show of hands, who's familiar with the largest contentful paint? Amazing. It's a Core Web Vital, something that many of you have heard of. Now, in the WA.com example, it was almost 3.5 seconds, but that was lab data. Now, if we look at the RUM data, RUM meaning real user metric, meaning what they are experiencing out there, real individuals, it was down to 1.7 seconds. Okay, interesting, but that tends to tell us, because web performance is really an investigative process, that tends to tell us like, okay, the WNBA site user might be on like a kind of a modern phone, maybe with good cell connection, that's fine. But this is data that we use in our audit. Now, in the case of the LCP, largest contentful paint, anything under 2.5 seconds is great, anything over 5 seconds is poor, and anything in between needs some work. Now, data also tells us that around 70% of LCP resources are images. Okay, so we have some more information. Now, in the case of this WNBA site that we were looking at, this was the LCP image. Probably a free throw going on right there. But it was request number 32. So outside of the actual first request, which was like the HTML, there were 31 other resources that were deemed more important. Now, we've always spoken about making sure that the critical resources are the ones that you load as early as possible. So in this case, the LCP is going to be a critical resource. So we want to make sure we minimize any kind of delay to get that LCP loaded or appearing on the page. So there are several ways to do it. Preloading the LCP, highly recommended, because again, you are positioning this item as a critical resource, and you want to make sure that it shows up as early as possible. And ideally, not going to be down the line in terms of the request. You want that request to happen as early as can be. So you can use the preload, or you could use the fetch priority API and set it to high. because once again, and I'll repeat myself, this is a critical resource and you want this loading as quickly as possible. Now, of course, you want to make sure you're loading an image using the image tag in its rawest, simplest form because it gets parsed early. There are ways to sort of delay, many ways to delay an image loading, but you don't want that. Just because you can load an image as a CSS background doesn't mean you have to do it. And two, you want to make sure that your LCP resource is never that one. Now, once again, I talk about comparing it to track and field. You know, we know that the 100-meter record is 10.49 for the ladies. The 100-meter hurdle record is 12.12. Hurdles are not gangster. You want to make sure that they're not in the way of getting the result that you want. So you want to make sure that the LCP has no hurdles in its way. Get that loaded as early as possible. Now, once again, 70% of the LCPs are images. Once upon a time, we believed that compressing, getting your image optimized was the answer to get it loaded as quickly as possible. Well, it's like not false, but it's complicated, right? As a famous politician once said, it's the network, stupid. The network. Now, the one thing people don't realize is that the network is, any chemistry, former chemistry students here, whatever, university, yeah. The network is what I'd call the limiting reagent. I mean, if you didn't, catch chemistry, you missed that. But, everything happens because of the network and will not happen because of the network. So we could have an image resource right there. You can optimize it, and you still have network challenges that keep this resource from loading as early as possible. This is like trying to solve sort of like a traffic issue by, dumping your Honda Civic and getting a Ferrari. The point is, you're still in traffic, and that's what's going to keep you from getting to work on time. Now, there's a great blog post, which I'll share like on Twitter, where they talk about minimizing the delays and splitting up the process, the LCP loading process, in 4 parts. But ultimately, what you want to do is you want to get that image resource to load as quickly as possible, to go to the far left as quickly as possible. All right? So this is what we think of when we do audits and we look at waterfalls and try to understand how we can get the loading process done as quickly as possible. Now, we're going to very quickly talk about the CLS, the cumulative layout shift. We're not going to spend a lot of time here, but on the website at WNBA, it was 211. That was lab data. The RUM data is 290. Ultimately, the CLS is about unsized content, the bad experience of watching the page jump up and down. Not so much a timing issue, but one that definitely does not create the best user experience. And ultimately, the definition's like this: CLS is a measure of the largest burst of layout shifts scores for every unexpected layout shift that occurs during the entire life cycle of a page. Things you just want to keep an eye on. And I kind of threw that in because it was part of the data that I showed earlier. Now, something that's going to be super important here is TBT, which is total blocking time. And this is where we start to talk a little bit about JavaScript. Now, total blocking time is it's when you add up all the long tasks which are longer than 50 milliseconds. All right? Now, on the site as well, again, the WNBA website, it was 7,614 milliseconds, just over 7.5 seconds, which is kind of a lot. And it's kind of a lot because when I look at some of the data out there at the 90th percentile, we are seeing the web in general, the web is in general has a TBT of just over 6 seconds. So the WNBA.com website is really like well past the median. Now, when we look again at waterfalls and audits, we look at, you can see this is a web page test example. You can see the long task and all those red bars, all right? This is the main thread getting hammered, and basically you're not able to do too much. So these are a bunch of long tasks, and we're trying to solve that. How do we minimize the long task? Because when you do not, you end up having things like rage clicks. All right. Now, who attended the workshop yesterday with Dr. G from Sentry? Yeah, and I think you folks remember that she talked about rage clicking, and when you're hitting the button that's inactive, a lot of times that's because the main thread is locked up from long tasks. All right. So we're trying to minimize that, and we want to make sure that there's a good user experience. Or, you end up with a user like this, period. Bad scene. But these are important because you run into situations like where the IMP, which is another metric that we looked at, which was listed up at the audit, which is interaction next paint. Again, we take a look at JavaScript execution, etc. But here we see this RUM data indicating to us that it's actually pretty good. Conflicting data, but once again, the RUM data shows us that the user of the WNBA.com website might be on a decent phone, might have good connectivity. Because this is what the rating is. 200 milliseconds or below, good. 500 seconds or more, poor, and everything in between is mediocre. And the Next.js site in general, at 41% IMP pass rate, this is what the report says from Core Web Vitals. Again, sort of like muddying the waters, like what exactly is going on here? But we're going to talk about that in a hot second. So when it comes to the JavaScript that's showing up as TBT, we want to break up the long tasks. All right? We want to see as little red as possible when we're looking at, say, data from web page test. We want to make sure that the main thread is not being hammered too much, just so that we can hit a buy button and get those, Jordans. So once again, I'm going to compare a track and field event for this. The 400-meter record is 43 seconds, which is pretty goddamn crazy if you ask me. But what if we broke it up? We broke up this long task into smaller pieces, say 4 by 1. The record is 36 seconds. So what happened there? We broke it up into manageable pieces to get a faster result. This is what we're trying to do when it comes to long tasks on sites. Break it up so that we don't have a main thread that's blocked all the time. Now, let's talk about something else that's fairly recent, which is the speculative rules API. And this is about prefetching and pre-rendering. Once again, what can we do to accelerate the process of getting to the result that we want, a snappy page? Well, we can prefetch the resources ahead of time, or we can prefetch and render the page, which is pre-rendering, ahead of time. There's some challenges there, but I'll get to that in a second. So you'd end up with something like this, with the speculative API, where you can actually indicate in a list the sites that, or the pages, pardon me, that you want to preload the resources, okay? When it comes to pre-rendering, which is a little bit more intensive, but if you could do it, why not? You could actually pick the site that you want in a list, but you could also add the eagerness that you're looking for, like, do you want this to be loaded ASAP? And there are some, ways to sort of like manage that. So you can have something like eagerness moderate here, but you also have immediate. all the way down to then to eager, then to moderate, then to conservative. They all have different ratings, but you're able to set how you want this page to be prioritized in the loading process. All right? And again, this is all information that I'll share in some tweets, and I'll post the slides so you can download them. Now, I talked a bunch about the RUM and lab data. RUM being real user metrics, what you and I are experiencing in this hall. All right? And there's lab data, which is, perfect environments, and it gives us also a reading of what it's like. All right? So, there are a number of ways you can compare it. I'll give you one in particular. Believe it or not, in the lab research, Viagra was supposed to treat sort of like a heart condition. And then they put it out in the wild. The real users, como se dice, it was a little different. RUM, lab. So I talk about that because we're in a world right now where it's really about the mobile phone. In 2016, the handset, the phone became the dominant device on the internet. That was 8 years ago. And it's not going back. And I try to remind people that because there are two users when it comes down to our devices. There are Apple users, iOS, and there are clowns. Shout outs to the clowns. Oh, people know. But serious matters here. So I was looking at RUM data from Akamai. They have this incredible resource called the RUM archive, where you can look at their networks and what they're seeing. Over 2,500 different Android devices. Blew my mind. And I remember one day I posted some of the info. These are some of the devices that were showing up on their networks, devices I've never heard of in my entire life. And I'll tell you right now, these are not iPhone 15s. Like, they don't have the guts of these devices that we tend to own. And, I'll say this. This is a report that came out recently. The low-end price segment experienced the fastest growth among smartphone categories. Phones priced under $150, I can't tell you the last time I paid $150 or less for a phone, unless it dropped off a truck. Grew by 30 million year over year from 90 million in such and such to 120, marking a 33% growth. These are devices that are showing up on the network, and we want to take account of that. Come see me after. I'll tell you about the story of Facebook, how they sort of did some research around that as well. So what I'd like to say, come on. Oh, come on, do not. There. Sort of like in closing, I know I've been speeding through some stuff, but I really want to give you an idea of what's going on. So this is the best part that everyone seems to like when they're going out. Tips! The first thing you want to do is test. Always test, always test. We talk about in performance, you can't improve what you do not, you can't improve what you don't measure, ultimately. You need to see where you are, where you're trying to go. We're trying to reduce latency everywhere. How fast can you get things onto a page? How fast can things get loaded? Can you reduce, the wait times? These are like chief items. Prioritize critical resources, break up tasks. What is the resource that you need to show up in the viewport, and how fast can you get that done? And again, break up the task so you're not hammering the main thread, because out in the wild, there's some phones out there that cannot handle what you are sending down the wire. And look at your data. Your data will tell you what your user is all about. The WNBA.com, luckily, the majority of their users seem to be on decent phones and have good networks. But what happens if, I don't know, Giants of Africa comes around and people in Nigeria are trying to hit that site? It's going to be a different story. So I know we're at CascadiaJS, so let me say this. There's no bad JavaScript, shockingly. Simply, there's better HTML and CSS. Right? And since this is probably like my last minute, speaking of HTML, you may have seen these stickers floating around. I have like 20 left. So whoever sees me first, you can have one. And the last thing I want to say is this. I mean, that was kind of like a general performance talk, but the one thing I'm trying to do is help with performance literacy, and I'm actually sort of getting ready to announce sort of like an event, performance-related event. So please, if you have like case studies, if you're working on performance at your company, you know, you want to talk about it, or you want to discuss a way of having like a conversation about these things, please find me on all of these platforms. Henri Helvetica, Twitter, LinkedIn, Instagram, Mastodon at times, and Blue Sky. And with that being said, merci bien, and talk to you soon.